Hi, everyone. Thanks for joining us today. This is the Measuring the Solubility of Gases with Soda Pop webinar. I'll go over a few housekeeping items while people are coming in, and then I'll launch a poll in a few moments as well. We have a fun poll question for you. So first off, we'd love to answer all of your questions during the session, so feel free to either use the chat feature or raise your hand. Melissa and I will be monitoring those in the background here. In a few moments, I'll put a link to a shared folder that includes additional resources that Noose is going to be using and going over today. So you have access to all of those. And then just to let you know, we are recording this webinar, so you will be able to find it on our website. And I'll put the link of where to find that exactly on the site closer to the end of the webinar today. And everyone will receive a follow-up email with links to the recording, the additional resources, and a certificate of attendance for attending live today. So I wanted to launch the poll real quick. And while I'm introducing your instructors, if you don't mind answering our question, we're just curious what you call a carbonated beverage or drink in your area where you live. And I'll let that go for a few minutes. So Melissa Hill is in our chemistry department. She's going to be helping to answer questions during the session. She has a lot of teaching experience at the college level. She has 7 years, including general chemistry, biochemistry, organic chemistry, and spectroscopy. And she's been working with Vernier for 10 plus years in product development. And she does a lot of our curriculum development trainings, and she manages a lot of our key projects. Noose is your other presenter today, and he has 34 years of high school chemistry and physics teaching experience in Frederick County, Maryland. He's been using our products for a long time, since 1984, and he has been with the company about 5 years, and he also is heavily involved in training, curriculum development, and answering your tech support calls. So I'm going to end the poll here. It looks like here, I'll share the results. More people call it soda, and the second runner-up was pop.
Okay, all right. We had a running discussion in the office when I wrote this experiment, and it was like, what do you call it? And then Melissa pops in there with, well, just call it Coke, and it's like, what? And so apparently Texas and I think Georgia, I was told that that if you order a Coke, then they will ask you what flavor of Coke. Okay.
Yes. I grew up in Texas, and I grew up calling it Coke for everything. If you wanted a Sprite, you called it Coke. I want what kind of Coke do you want? A Sprite. So I had to change what I called it when I moved to the West Coast, and
oh, it's just kind of fun. Yeah, it surprised me when we were putting this together. And so let me tell you a little bit about what we're going to do. My name is Noose Hissom, and I've been using Vernier equipment since 1984. I've known David a long time. The company is closing in on 40 years, and I've been happy to use his equipment for 35 or 6 years of that time. And I taught chemistry mostly. I taught a little bit of physics, but a whole lot of chemistry. And so today what we're going to do, let me back up here just a bit, is talk about solubility. A lot of us teach it in chemistry. I think we all teach it in chemistry in first year high school, particularly. But what we tend to do is we tend to look mostly at solids. I mean, makes sense. But we talk about gases, and it just hasn't been as easy to come up with a way to look at the solubility gases as I hope that you find this experience. So that's the plan. And then the other thing is we are going to showcase our graphical analysis software, which allows you to share data remotely. It does a lot of other things, but for what we're going to do, and certainly in this time of pandemic, we found a number of teachers have found this very valuable. So we're going to give you some live data. So the idea is unless you want to just sit there and watch, you're more than welcome to do it. You can actually actively participate, and so we're going to hopefully you'll be doing that with us, and so we'll see. And then just some things about Vernier that many of you that are Vernier customers probably already know. One of the reasons why I stuck with Vernier for years before I came to work in Oregon, like I said, I taught in Maryland, was just their support is just amazing, because we're all teachers here in the tech support group, and specifically to certain topics, and so we kind of understand what's going on in your classrooms. At least we think we do, and we try to accommodate that, help you as much as we can. And so the other thing that's come up in this last year and a half is, do you have any way to support remote teaching? And yes, we do. And we're going to showcase graphical analysis today, but there's some other things. We have some remote data. We have some sample data sets that are out there that you're welcome to use. And so on our website, there's a whole remote education area. By the way, this slide deck is in the shared folder, and so don't feel like you need to write anything down. You'll get all this stuff. And so let's do a live demo together. So here's what we're going to do. Okay, here is my computer, and here is my iPad. And what we're going to do is we're going to set you up. So if you want to participate, you need to launch graphical analysis on your device. So if you have it on a different device besides the one you're watching the webinar on, that would be ideal, because then you would not have to switch screens as much. But basically, when you buy graphical analysis, or when you get the 30-day free preview, you get this code that turns. Whoops, can't do it with the slide deck running, so I'll type it in manually. You get this code that you have to put into your free version of graphical analysis, because graphical analysis is free. And Melissa or Angie will probably type this code into the chat box so you can copy and paste it if you're on a device that allows you to do that. On a like an iPad or something, you would have to type it in. But this is a one-time thing. So even the 30-day free preview, you can you can share this with your students, try it out. It's not something that you have to do every single time. You just put it in there the first time, and when you buy it, it's good for a year. And so runs until the end of June, the 1st of July of the following school year. So, and it's a one-time, it's a one-cost thing. So it's not by this number of seats. You buy a subscription for your school, basically. So if I typed it all in right and I submit it, then what should happen, and of course this is telling me that I typed in something wrong here, capital EGHXV, small t, capital K, 3, what is that last letter, Melissa? Is that an I?
Yeah, I think that's a capital I.
I thought I had that in there too, but anyway.
Could be a lowercase l, I suppose.
Yeah, we asked the programmers about this, to try to make it not so hard, especially when you have to type it in on a device. It's kind of a little bit annoying. But sometimes it works, and sometimes I'm going to try a 1 just for kicks here, see if that works. Nope. So Melissa, did you get it to work?
Oh, I've just used it on my computer. So
okay.
Yeah,
so,
it works on the computer if you copy and paste.
Okay, let me see. Yeah, so I must be doing something. I'm going to copy and paste it, but to do that, I have to. Did you put it in the chat?
Yeah, it's in the chat.
Okay. All right, I'm going to go grab it from the chat, because I deactivated my pro version just so I could demonstrate how to do this, and unfortunately, I'm not. Looks exactly the same when I posted, but now it's working. So I must have added an extra character or something like that. So I'm going to get my iPad out of the way so give us a thumbs up in the chat if you got it to work, or if you didn't, you can talk with Melissa and maybe she can help you to figure out what's going on. But let me show you what we're going to do here. The experiment is in the shared folder too, and this is one that I wrote. I don't know. 2 years ago, I think, when we first started talking about the food chemistry book. And so my flat soda pop. And so the idea here is to try to find a way to show, a valid way to some extent, to show how gases are dissolved in solution. And so, most of us use some sort of a chart similar to this one for solubility, right? That's a pretty common chart. And in our chemistry with Vernier book, the potassium nitrate line is one that is very commonly done. That's this experiment here in our book, Chemistry with Vernier. So you basically create a saturated solution, and then you allow the thing to cool down. And as soon as the crystals start to form, you note the temperature, and you plot that against the mass of solute that you had dissolved to create these saturated solutions. And it's a good lab. It works really well. You get good data. You get a nice solubility graph that looks extremely similar to the one you expect. But these dotted line ones, I never did an experiment with those. I had a soda stream, and I would, dissolve some carbon dioxide and show students how water became carbonated. But I never really measured it. So that's what we're going to do today. We are going to measure, at least to some extent, and I'll explain what I mean by that in just a second. The amount of carbon dioxide that's dissolved in a fixed amount of liquid, and then there's some extensions we'll talk about at the end. And so what I'm going to do is, and this is a sensor that we don't typically use a lot in chemistry, but if your school has carbon dioxide sensors, you can do this with either type, the Go Direct one or the plugged in one. This experiment would work perfectly well with the older style BTA carbon dioxide sensor. So here's my lab setup. I've got 150 milliliters of chilled soda sitting here in the beaker in the ice water bath. And so what I'm going to do is I'm going to set graphical analysis up the way that it says, which I did in advance to save a couple minutes. So I changed the time scale to 120, and I'm only showing the carbon dioxide graph. I just need the meter for the temperature. And so the other thing that we're going to eventually need is we need to keep track of the amount of carbon dioxide produced and also the temperature that the solution started at. And so I made a chart. I shared it in the shared folder. So if you open up, there's a table in there, and you're welcome to use this if you want to use this experiment. Your students are going to need this for a manual plot at the end. We're going to all do a manual plot. So you're going to, if you want to do it with me, you're welcome to do that. So anyway, let's collect some data. Deuce is talking way too much. Okay, so what I'm going to do is I'm going to set up the first one. I'm going to get my iPad out of the way. And so what it says to do is it says to take 5 milliliters of solution and put that into the Nalgene bottle that comes with the, what I didn't do is the first thing it says to do is measure the temperature of the cold solution. So I'm going to dump this. And so we'll go ahead and the temperature probe is in there. Let's get that temperature so you can see that it's pretty cold. I have it sitting in an ice water bath. I don't expect it to freeze in there. I don't have salt in there or anything like that, but let's get a nice temperature for that. And I'm going to, just because I'm old school, I'm going to go ahead and keep notes. Oh my gosh, I'm going to write something down in this day of technology. So get myself a little notepad here so we can write the temperatures down, because we're going to do a manual graph at the end here. It is possible to set this up as an events with entry. It turns out that I think it's a little more trouble to do it that way. But all right, so it looks like I'm close to 4.4 degrees Celsius for my first trial here. I'm going to be heating up the solution there on the hot plate, and so let me flip that on. All right, so let's get. The lab says to take 5 milliliters of solution. And what we're going to do is we're going to measure the amount of CO2 that comes off of this and use that as kind of a model for the CO2 that was dissolved in the solution. So, I looked at other ways to do this, Henry's law with a pressure sensor and things like that. And what I like about this is that it's CO2. We're measuring CO2. So I'm going to go ahead and start collecting data. And I'm going to turn on the the stir. Meanwhile, while that's running, I'm going to take my cold bath and I'm going to stick it on a hot plate. You need to make sure that your hot plate is not too hot. You'll have to probably stick a temp probe into your hot plate and allow it to, this shouldn't be going that fast. I'm talking and not paying close attention. Allow it to heat up and kind of monitor with your hot plate how fast it warms up. With this one, you want about a 5-degree difference between samples, 5 or 10 degrees. You don't want the thing to shoot up to boiling or anything like that. Just kind of a gentle heat. Okay. And so you might have, like this particular hot plate, I fiddled around with it, and then it has an on-off switch, so that was kind of handy. Otherwise, depending on your hot plate you have available to you, might have to fiddle around a little bit. But so the idea here is that the CO2, by agitating this, the CO2 is being released. Whether it goes completely flat or not, that's kind of up to you. In 2 minutes, I got decent data. We'll see today how our data comes out, but data that was pretty representative of what we would have expected with a gas that's not very soluble. So it's coming out a solution. So so that's what we're going to do, is we're going to let this thing run for 2 minutes. And so another thing to think about is it's a kind of a controlled experiment in the sense of I'm using 5 milliliters of solution. I'm letting it run for 2 minutes, kind of under the same conditions, so that the only variable that I'm changing, the controlled variable, if you want, is the independent variable is the temperature. The amount of CO2 that comes off is proportional to that. Now, in graphical analysis, I can keep track of each of these runs a little bit by going into the data table and renaming the run. So I can go in here and say, okay, this run was what was it? 4.4 degrees was the solution temperature when I started it. So I can rename that one, and that way, I'm keeping track. I mean, if you're writing it down, that may or may not be important, but let's see, what's my temperature is 8 degrees. It would be nice if it was a little warmer than that, but I think we're going to be okay. While I'm rinsing and cleaning, it should go up another degree or two. So I'm going to go ahead and set that aside. It is possible that the CO2 sensor may get a little moisture on it. It's not a bad idea to wipe it off. Let me go ahead and turn that off. How do I get the CO2 out? Oh, use a property of CO2, right? So what we're going to do is we're going to fill the bottle up with water. So we're going to drive the CO2 out of the bottle. And then we're going to dump that. I have a very, very expensive waste container here. I'm a big fanatic of 2-liter bottles. I used them for just about everything that required a large beaker. As long as I didn't have to heat it, it was perfectly fine. All right, let's see. Let's get my next sample here. So yeah, not bad. 11 degrees, started out at 4 degrees. That's not too bad. Let's take a note of that. 11.7 degrees, we'll call it. Take that sample and we'll get 5 milliliters of that. Are you guys getting the data? Give Melissa a little heads up if you are. That would.
You haven't shared it yet.
Melissa,
So,
thank you. That's why I need Melissa.
I was going to remind you to do it once you started data. You were doing a lot of moving around the pieces, so I don't want to.
Okay. Oh, let's share. All right, this will be cool. Actually, this is going to work out really well. So here's the deal. I'm going to go ahead and start collecting trial number 2. Okay, and then I'm going to share data with you guys. Okay, so let me get the stir turned on, start collecting. Here's how you share data remotely with your students. And you guys are the students and I'm the teacher right now. And so what we're going to do is we're going to share remotely. So on my end, I tap on this little uh, Star Wars TIE fighter is what I like to call it. On your end, what you're going to do is, let me bring my iPad back over here so you guys could see it. You're going to start a new experiment, and you're going to, when you start a new experiment, I'm going to bring my iPad over so you can see what I'm talking about. So let me bring this over. What you're going to do is tap on data sharing. Okay, so start a new experiment, tap on data sharing. Okay, I'll get that guy out of the way. And I'm going to send you a code. And in the data sharing, you're going to get a choice for remote data. And here's the code right there. So if you're on your phone, you probably need to type it. If you're on your computer, Melissa can copy and paste it into the chat. I guess I could do that too. It gives you this little doodad here where you can copy, and then you can go into, like, if your students are on a chat with you or something like that. Where'd my chat box run off to? Oh, there it is behind my iPad. Let me get that around here. Then, you could, if you're in a situation where you can copy and paste it. And so what should happen is when you put that into the data sharing box, that code, I did put it in the chat, so if anybody needs it later, you should be getting data. Is it working, Melissa? Is it working? I don't know. You haven't typed it in yet.
Yeah, I was making sure it was in the chat. Let me make sure
thanks.
I can get your data.
Yeah.
Yeah, I'm getting it.
Okay.
Hey, that's how quick it was. I typed it in, and now I have your data.
Okay, so this run. Let me go ahead and put the table on here, and we'll rename that one. This one was our one that was 11.7 degrees. And you should be getting all this from me. You may not see the table. Sometimes those things you have to turn on and off yourself. But the previous run, if you look on the y-axis label, you can turn that one on so we can compare them. And is it doing what we kind of expect as we warm up the sample? I think it is. Yeah. Let me go ahead and do a new one. So I'm going to turn this off here. My hot plate might be getting a little hot here. I may back that down a little. Don't want it to heat up too fast. But I think you'll get the idea. We'll run, ideally, I'd like to run 5 data points. What's the time look like? We're getting about halfway there. I think we do have to do a manual graph, and so I definitely want to leave time to do that. And get my magnet out of there, dump the water out, put it back in. All right, let's see what our temperature is for this run. The temperature is 23 degrees, so it's nice and toasty. Let me put that down, 23.8, I'm gonna call it, degrees. Let me get that sample. And we'll get, once again, controlled experiment. So the only thing that we are changing is the temperature of each sample. Everything else, is same volume, same, time for the run for it to allow it to give off some CO2. So is this the exact CO2 dissolved in the water? No, right? Because there could probably be more. But it's a measure of it. And so this is one way, as you can tell, I hope, it's not very difficult to set up. It's not very difficult to run. It goes pretty quick. I'm talking, and, ideally we would want the students to do maybe, 5 runs would be ideal for this, so that you get some points that would be, 3 is really a small amount. Depends on the time, that you have to do, but so what's happening, the CO2 sensor, the reason I like using it is we're measuring CO2, and we know that the carbonated beverage, soda for most of our population at the meeting today, is the carbonaceous as a result of the carbon dioxide dissolved in the water. Yeah, if you have access to a soda stream, it is kind of fun to make carbonated water right there with your students. We used to do that, and then we would, I got a lot of bathroom cups, from Costco or Sam's Club or something, and we would, add some flavor to it, and so they was kind of like, a lot of kids, other than buying it from a grocery store, there's no real image of how this stuff gets done. And so that's kind of a neat way to show it. But I never tried to measure it. I wrote an experiment that I'm going to share at some point for doing the equilibrium of carbonic acid by measuring the concentration of CO2 using Henry's law, and that uses a pressure sensor. And that certainly valid, and we could probably do something real similar here. But the CO2 sensor just seemed to me, I can remember years ago, David Vernier, when he came out with the CO2 sensors, like, why aren't the chemists using the CO2 sensor? And it was like, I don't know, Dave, there's just not that many experiments that we've written that use the CO2 sensor, or have the need for a CO2 sensor. So, it was one of those things where when he would complain about that, it's like, I try to think of what could I use it for? And it wasn't that I wrote this because of that. I mean, it's just, I like the idea of measuring the exact thing we're talking about rather than something like pressure, which of course is valid, but a lot of gases have pressure. So let's do one more point, and then that'll give us plenty of time to do the analysis together. So is everybody getting the runs?
Yep,
If you want to
coming through.
If you want to look at the other ones on your end, just tap on the y-axis label and you can switch and look at the other ones and compare them. And if you want to fill in that table, that shared table that I gave you, I'm going to eventually need to write those numbers down anyway. So if somebody wants to do that before I do, that would be totally fine. What we need is the final concentration in parts per million of the CO2. So we're going to need that for our manual entry. So this experiment does use graphical analysis in a couple of different ways. All right, where's our temp? 32.9, not bad. 30, we'll call it 33. I'm going to call this the last point just because I want to make sure that we can get to the other part. And I just want to, I don't want to run out of time. So all right, 5 milliliters. There we go. Put that back on there just in case I change my mind. I don't think I will. But by the way, you may notice I'm agitating this a little bit too. If you don't have a stir, you could certainly have your students stir it manually. But I do find that the results come out more close to what, the typical solubility curve, which is what we want our students to see, something like that. So. All right, so let's do this last run. Any thoughts while we're doing this? Anyone have any questions or concerns, or Noose, you're not really measuring the solubility of CO2? Anything like that?
Nothing's come in. People are getting good data through the data sharing, so that's great.
That's cool.
But yeah, maybe tell us a little bit more about how this compares to the typical one, because I know, and you even mentioned, we never did this when we were teaching. You never did this when you were teaching, but we always did that, dissolve the KNO3 and look at the solubility of that one.
Yeah.
But how would you teach it now with this lab?
So I would still do the solids one. I mean, that's, certainly something that needs to be done. And so that was this one that I shared. It's in the folder and you're more than welcome to use it. The one I put in the folder is the one for graphical analysis. We have it for LabQuest. We have it for Logger Pro. But basically what the students do in this one is they set up 4 test tubes with different amounts of solute. Okay, so they measure the amount of solute, which corresponds to, they're going to put 5 milliliters of water in each test tube, and then they're going to multiply that out to get the amount it would be in 100 grams of water, which is the common way that solubility is represented, right? Is we commonly represent solubility as grams of solute per 100 grams of water. We'll talk about that for this lab here in a bit. And so this is not, this is a pretty common experiment in Vernier land. It does use what we call events with entry data collection. Works really well. I will tell you that the ones that have more solute when they precipitate, so what happens is you boil these in a hot water bath and you heat them in a hot water bath. And what happens is you end up with an unsaturated solution and you let the thing cool down. And when it just reaches saturation, you'll start seeing crystals form. These top two ones, that works pretty fast. You get crystals within a few minutes, but the bottom two ones really have to cool down a fair amount. I do allow my students to use a cool water bath for these bottom ones, and you get the points, spread out. I mean, because of the way these are selected, you're going to get a graph that's, if you look at the potassium, I don't show the potassium nitrate graph right away, but we do talk about saturated, unsaturated, supersaturated with sodium acetate. And so you can see that based on this graph, the 160 is going to be way up here. And so you're going to generate basically this graph. And so this is what we talk about all the time. Oh, I bet my run is done. Oh, there we go. And so, yeah, but let's look at this one. After we're done with this, let's look at this one and see how it goes. Let me go ahead and rename that last one. And then what we'll do is we'll go ahead and transfer the data. If you've already done it, that's great. If not, you may not have the max values yet. Let me type that in. That was 33 degrees. All right, so what I'm going to do is, let me turn the stir off just so it doesn't drive us crazy. I'm going to take this CO2 sample out, our sensor out of the flash, just because sitting there in a moist atmosphere is kind of hard on the sensor. Okay, let me fill in this. So what the students have to do at this point is they have to fill in this chart. Let me go find it for you and pop it up on. I'm going to take it out of here so I can set it. Woo, there it is. I want it off there, right there. Okay, and I'll get my graphical analysis. And so we know that our temperatures were 4.4 degrees, and what was the other one? 11.7 degrees. We'll use this chart in just a minute for the manual entry. And then what was the last one? 33 degrees. Now, concentration of CO2 after 2 minutes. Let's go to the graphical analysis graph. Pretty easy. You tap on the graph to analyze, do an instant, we call it examine. So if we want to know what the concentration of CO2 was in the bottle after 2 minutes, there are the values right there. So I'll just fill in, let me see if I can slide this over a little bit so we can see both. So that the first one was 9,056 part per million, 7,003 part per million, and then 4,091 part per million, and then 3,106 part per million. Okay, so that is all data that we can take from the graph that we created. Now, at this point, if you want to keep a record of this would be the perfect time to do that. Okay, go to the file menu and do a save. Okay, and then depending on your system, you would, what we tell instructors is, if you've got if you're on Google, if you're using Google, which is a pretty common cloud service, save it to your drive, but be careful. On Chromebooks, a very common issue that happens is the default on a Chromebook is to save the data to the local Chromebook. The folder is typically called downloads. You want to make sure you save it to your drive so you can get to it when you're home or if you're on a different Chromebook. So be careful about that. Let's see, solubility of CO2. Okay, save it somewhere where it's going to be easy to get to. If the kids are going to make a report, in graphical analysis, they could take this graph, and you saw how it can turn on a legend and all kinds of things like that. And then the kids can make, they can export this as a PNG and use that as in a lab report. Okay, so that kind of thing is something that a lot of teachers want to know how to do. And but we're going to do a manual entry. So I am going to disconnect from you. Okay, so you are going to lose connection to me. So if you want to play, you have to do a little work now. So I'm going to tap on this thing, and you'll see it says stop sharing. So in the Vernier world, when you are sharing, you're typically sending data. You're not sending analysis to your students. And so now I'm not sending you anything. You're on your own, okay? So I'm going to start a new experiment. And this time I'm going to, and I did save it, but I'll just do it again just for kicks here. I'm going to do a manual entry. Okay, and if you want to follow along, absolutely, please follow along with me. And you'll, because we are going to build the archetypical solubility graph right now, but we're going to do it for gases rather than for solids. So my x-axis label, I'm going to tap on the 3 dots next to x. That's going to be my temperature, and that'll be in degrees C. Oops, how about a capital C? And my y-axis is going to be the concentration of CO2. So I'm going to call that concentration. You can call it CO2 if you want. And that's in parts per million to start with. We'll talk a little bit about, can we make this traditional? Yes, you can. Okay. And then it's just a matter of typing in the values. That's why we needed this chart. So 4.4. And you're on your own. If you want to follow along, you're welcome to do it. But if you want to do this with me, by all means, do it. We only have 4 points here. So it's not going to be like an onerous amount of work here to type this in, even if you make a mistake. Let's see, 9056. The points should start appearing once I put the other coordinate in. 34091 and 3106. So this is the same number of points as you would have in the solid lab. Okay, and then typically what we want is we want something that comes close to the classical solubility graph. I don't need the data table anymore. To turn the data table off, top right corner, if you tap on the view options menu, this little box of boxes, you can turn the data table off because we don't need it. But what we would like, and back in the old days, before a lot of other stuff, I used to have the students print this out and I'd just have them try to put a hand curve on here. But graphical analysis is so slick, you don't really need to do that. You can have it do it yourself. Bottom left corner, we'll pick the graph tools and we'll do a curve fit. Now, graphical analysis always defaults to a linear fit, but it's not a very good fit. Have your students fiddle around. Okay, a quadratic fit, yeah, maybe not too bad. Let's try a power fit. It's not so bad. An inverse fit, well, that doesn't look very good. How about a natural exponent? Yeah, okay. How about a natural log? Okay, you need to find a fit that, because we don't care. We're not going to do anything mathematically with this. We just want something nice to fit the graph. And so, you're welcome to kind of fiddle around and see which one. Now, one thing you might want to take into account, and I didn't do that right now, is you might have your students actually do a little bit of extrapolating. And if you're going to do that, you probably want to be careful with your fit and your axes. So I don't care about this box at all. I'm not going to use the function. I'm just going to kind of slide it out of the way. But what you might want to do is, if you look at a typical solubility graph, it's the x-axis particularly is going to usually go from 0 to 100. So if I tap on the y-axis, if I tap on the graph tools icon, the little mini graph, I can go and I can adjust the graph options. And so I can make my temperature go from 0 to 100, just like on a normal solubility graph. And that's probably desirable for a couple of reasons, because we want the students to possibly extrapolate the data. And the same thing with the, scaling your axes from 3106 to 9052, that's silly. Let's go from 0 to 10,000. Okay, so that we have, some kind of a, nice looking graph. And so you can see that this is now starting to look a little more like, our archetypical solubility graph. And so, just by scaling it around a little bit, you can make it look like that. If there's questions that you ask, like, well, what would be the solubility at a higher temperature? What you need to do is turn on the interpolation option. It's under the graph tools, turn on interpolate, And now the students can go anywhere. You can ask them questions like, well, what's the solubility at 10 degrees? What's the solubility at 20? What's the solubility at, at body temperature, when you drink this stuff. And so by turning on the extrapolate option, you have that ability to ask questions like that. And you'll notice in the experiment file, I put it in there. There are questions that say, what is the solubility at different temperatures. We in Vernier always give you the experiment files in both Word and PDF format. So if you want to go in here and change these to different temperatures, maybe ones that are higher than what you collected, you absolutely have that ability to do that. Once you buy our lab manuals, it's our lab manuals are the cost of the lab manuals is one per your department. And then you can use that with as many students as you want. You get the electronic copies of these files, and you can change them. So, I taught AP Chem for 25 years. I used to take these experiments and, take questions from Brown and LeMay or take questions from Zumdahl and just stick them, in these lab, do the pre-labs. I used to love some of the pre-labs from Brown and LeMay, and I would just put them, in the activities. So this lab, if you haven't noticed already, is from our new food chemistry lab manual. I want to point out this last paragraph without getting too hung up on it. And, archetypically, we want to have a graph that looks like a standard, grams of solute per 100 grams of water. Now, this gets to be kind of an advanced sort of thing, but it might be kind of fun to have your students fiddle around with this. In order to do that, we have to make some assumptions. We have to say the carbon dioxide was released by the solution. So we have to figure out a way using some gas law manipulations of taking the parts per million and converting that value to grams of carbon dioxide. And then if you go back and look at the original, the way I ran this, I ran it with 5 milliliters of liquid every single time. So though that mass of carbon dioxide that we measured, we're making a small assumption that it all came from that 5 milliliters of solution that we started with. Where's the 5 milliliters? It's right here. Okay. And so this is kind of a neat way to start combining some concepts here. Now, have you taught gas laws yet? Maybe not. So maybe this gets put off till later. Remember, you can edit this lab, turn this into an extension question, or come back to it later in your course. But you can you can do some not terribly difficult calculations. Great opportunity to talk about what does ppm mean and how does that relate to moles per liter or milligrams per liter or whatever. This early in the course, that might be something where you're talking about units and unit conversion and things like that. Okay. So probably because he shared it after he named the first data set. Is that what did I goof something up, Melissa?
No, that's that same bug we keep talking about, that when you data share, the table labels are different for you than for those that you shared it to. The axis labels are updated, but the table isn't. And so that's just a software bug. And we hope if you do share it after you've collected all the data and changed all of it, it does pass correctly. Okay. But it doesn't do it live. So we're hoping they can get that fixed. But yeah, we at least the data's there somewhere. It's just in the axis label and not in the.
Yeah, that's kind of annoying, but I wonder if after I stop data sharing, whether they can go in and edit those. I would assume they could. They could go in and edit those and fix them and stuff like that. So,
yeah, once you stop sharing, they can do all that. Yeah,
okay. So I hope this is helpful and interesting. I wanted to show you a couple more things since we have a few minutes here. If anyone has any questions, please don't hesitate. We have a nice small group here. So, it says actually you can't change the data set name, but as she said, it's present in the graph. Interesting. You can't change it once I stop sharing. That's definitely an issue that we need to talk to our.
Really?
we'll try to.
I feel like I've done well. What? Yeah. I don't know.
We need to definitely
don't have
talk
it up anymore, but
Trina, you should be able to do that. So we don't like that, and we're going to get that fixed.
You should be able to. Go ahead. I mean, make sure you're doing it from. It says, but won't change to it.
Huh. That's interesting. Yeah. We don't want, neither Melissa, as you can tell, neither Melissa and I like that. So we will definitely look into this, and we'll talk to the software guys, because you should be able to manipulate that all you want. I agree with you, Trina. We'll make that work. I just wanted to show you a couple other things. You have Graphical Analysis Pro now, unless you bought it for your school. You have it for a while. I don't remember what this one gives it to, like the 11th of October or something like that. And if you want to use that same code, it's in the chat. If you want to use that, try it with your students, you're more than welcome to do it. Let me show you a couple of other things that are part of Graphical Analysis Pro. If you want to save this graph and you want to follow along, by all means do that. Right now would be the perfect time to save it if you do want to do that, because I'm going to show you some other stuff, and if you want to follow along and try it with me, you're welcome to do it. We actually, Melissa and I stole this from Melissa, this list of all the cool things that Graphical Analysis Pro does compared to the free version. And you can see that the free version does a decent amount of stuff. All of the experiments from our lab manuals can be done with the free version. So don't think you need the pro version to do the experiments. You don't. The pro version gives you this option to share your data remotely with your students, or a friend of mine taught AP Chem in New Jersey last year, when during the worst of the pandemic. And what he did was, with Pro, is he had two of his students, well, he had his group kids in about 3 to 4 group to a group, and they were doing that hybrid thing where some of the kids were at school and some of the kids were at home, and Steve was like lamenting the thought of having to do the experiments twice. And I said, why do them twice? I said, you set it up so that every lab group has kids from the home group and kids from the school group, and then the ones at school collect the data and share it with their partners at home. And it worked. He said it worked really well. And he was doing stuff like titrations, which is, that's a pretty tedious thing to do regardless of where you are. His school did allow the kids to use their cameras on their phones, so they were able to see what was going on, the ones that were at home. But another feature of Graphical Analysis Pro, which is really kind of cool, is the fact that there's some built-in experiments that have videos, and the chemistry ones, Melissa did all of them. If you look here, if you do a file new and you get this menu and you click on see experiments, you can filter by subject. I'm going to filter by chemistry. You can also filter by which book. So if you have our advanced book or our regular book, you can filter those. But there's different experiments here, and all of these have videos attached to them. The time-based ones are the ones where the videos are synchronized to the data. So like this molar volume of a gas experiment is a time-based one. And so what Melissa did is, while she was collecting the data, she also took a video. So you can play the video, and so you'll get to see, Melissa setting this all up. Those are Melissa's beautiful blue hands there. Okay, and this one, if you're familiar with this experiment, you're going to react magnesium with hydrochloric acid, produce hydrogen gas, and you're going to measure the volume, the temperature, the pressure, and then use a little gas law action to determine the molar volume, 22.4. But what's really cool about this is that at some point, when Melissa starts collecting data, and you do have to take note of that. Now, in this particular file, I believe that she did that for us. If you tap up here on this little curly Q that's next to the TIE fighter, you can then also, over here, this little Hollywood showboard sort of thing, you can synchronize your data to the point in the video where the data actually starts getting collected. So if I play this back from up here, then what it does is it shows the students the setup, and you can see that she artfully sped up some of this stuff where it's just setting up the equipment. All of this is straight from the experiment. So the students could read the experiment, it says do this, it says do that. And then once it gets to the point where the data is being collected, then you'll notice over here on the left, it'll actually show the data as it's being collected. Now, this isn't physics, throwing balls and pushing carts, it's one thing. I mean, but the students can see how she manipulated the syringe to inject the hydrochloric acid. She zoomed in very nicely so the kids can see the little bit of magnesium reacting with the hydrochloric acid. This little jump up here where she had to account for the volume of hydrochloric acid that was injected into the system. All of that is reflected. This is all synchronized so that when you're showing this way, and I don't know what happens if I stop and start, but it actually synchronizes to the video. So if you kind of later go back and examine the data like I was doing earlier, it actually stays synchronized with the video. Now, not only did we do a bunch of these, but you can do it too. If your students are collecting data and you want them to demonstrate how they did the experiment, they can collect their data, and then they can also add a video. In the pro version, you'll notice this option. So if you're doing a new experiment and the students have collected the data, throw a quick thing up here so we have something, you can insert a video. And so the students can take that video with their phone, insert it with their data. They don't necessarily have to synchronize it, but they can have it there so that they can demonstrate to you how they did their experiment. And this is all part of Graphical Analysis Pro. I think these are the two big things: the remote data collection and the ability to add video to your data and synchronize it. Sort of reminiscent of Logger Pro. A lot of us old-time Vernier people love the abilities in Logger Pro to manipulate data, have videos and analyze videos. It's related to that. It's not exactly the same, but it's very close to related. The other things you might notice that are kind of specialty sort of things is to look at some of the options you have, like in the data table and the curve fits. And so if you open a data table and you do a calculated column, it's super useful tool in graphical analysis. If you do a calculated column, under the expression option, you can insert your own custom expression. Now, all of these that are already there that come with the free version, they match all our experiments. So you can do all our experiments with the free version. But the custom expression, I had a teacher ask me how to convert pH to concentration of hydrogen ion. And, there's no particular expression here that works super well for that. And so, I could take the pH value and, make that the exponent of 10 or the negative exponent of 10. And you can do that with the custom expression. So, which is easier to do than some of these other built-in ones. Some physics teachers have a lot of uses for that. And that also applies to curve fits. If you really, really, really wanted to fit some kind of a crazy curve, I don't know what it would be, to this data we collected, you can do a custom curve fit as well. So under the apply curve fit option, you'll notice there's an option for custom curve fit, and you can type in an expression here, and then you can name it. Okay, so I don't have much need to do this. I don't have a good example for this, but once again, in a lot of the physics type experiments, this has been found to be something that a lot of customers asked. So in our presentation, we put a bunch, we put a bunch of things that, because we get this pretty common, what can you do in pro that you can't do in free? And so Melissa had made up this nice little chart, and I just kind of copied and pasted it in so people could see the relationship. What does it cost? It's $100 for most schools. It's $100 a year for a subscription. So it depends on the number of students. We have a 2-tiered subscription model for this. And so if you're 99 students or less that are going to use this, oh, sorry, they changed that to 100. So less than or equal to 100 students, then it's $99 until the following July. Yeah, July 1st. If your school is larger and you're going to have more than 100 students using this, it's $149 subscription. Hey, Noose, if I collect data in Graphical Analysis Pro, what happens to my data if I let my subscription lapse? Nothing. Your data is perfectly fine. Even your videos will still be there. You just can't access them with the free version. So don't feel like you got Pro this year and maybe you don't need it next year, so you don't get it. The data is safe. The data will still open perfectly well. Believe it or not, the videos are still hiding in there too, but you can't see them because you're not running the Pro version. So if you have an interest in this, there is a free 30-day trial. Now, what I gave you, I don't remember the expiration date. I think it's a couple of weeks. But you can get this 30-day trial, and you can use it for a month with your students and see if there's things in there that you find that you can't live without. Particularly, the way things are going now, who knows what the school year is going to be like. It might be nice to have that ability. You set up an experiment somewhere, and then you share that, like I just did, with your students through the web. And so it might be nice to have that in your back pocket, or if you're going to a hybrid situation, you could have your students sharing the data with each other. The beauty of graphical analysis is, I hope some of you found out, was it runs on anything. So whatever you need to run graphical analysis on, it can run on a computer, it can run on a Chromebook, it can run on an iPhone, it can run on a tablet, not just an iPhone, any phone. And so it's a nice piece of software because it kind of crosses over everything. And the beauty of the interface is it's exactly the same on every platform. So you guys, if you were running this on a PC, it would look the same. On your phone, it would also look the same. Okay, just a couple other things I'm going to point out, and then I'm going to just call it good for our hour. If you need to contact Melissa, me, or Lane, that's the chemistry department at Vernier. Chemistry@vernier.com is a direct email to the three of us. Yeah, we all have our specialties a little bit. I'm kind of a high school, middle school, that kind of specialist. I can fake a little bit of college, but very frequently what I end up having to do is go to Melissa and Elaine and say, hey, what are they talking about? But we'll all see the email. You can certainly call and ask for us. If it's a general question, any of their tech support people can help you. But if it's chemistry related, please just say, hey, I got a chemistry question, and they'll try to find one of us. It's one of the tenets of Vernier is that if you call during business hours, you are not going to talk to a machine. You're going to talk to a human being. And I've had a couple of times where customers were caught off guard, like they were expecting to have to, go to a voicemail, and we don't do that. So please contact us if anything we can do to help. Can this experiment be done with Vernier equipment you already own? Absolutely. Absolutely. I mean, you connect your CO2 sensor, whether you're using graphical analysis, because if you have a LabQuest interface or a GoLink, you could do it that way. You could collect this data on Logger Pro on a computer, on a Mac or Windows computer. Logger Pro does not work on Chromebooks. You could do this with a LabQuest, and it would work just fine. So we just got a couple minutes left. Is there anyone that has any thoughts? Trina, you are great. Vernier's always been good at 20. Yeah. Thank you for that comment. Is anyone else? You too, Trina. Trina, if you want to unmute, you're welcome to do that. Any thoughts, questions, concerns? By the way, I ask the question and I don't give you a chance to respond. Food chemistry with Vernier is where I took this experiment from. It's relatively new. Idea being, let's take common chemistry concepts. I did link all these to NGSS, but I also linked it to common experiments that we all do in chemistry, but I linked them to food. And then for things that I needed, like Melissa's an expert in spectroscopy. It was like, let me let her do the spectroscopy stuff. So we had some other options here, but there is a section in the lab manual that does show you the chemistry concept and the experiment from this book that you could use. You know, if you're doing a titration, right? Well, am I drinking an acid? Because you can bet that the rest of this soda that I used, let me get the camera up here, is not going to get wasted. Okay, here is the soda that I used. Okay. Oh, I remember we were talking about this earlier too. Do you get the same amount of carbon dioxide from diet soda as regular soda? What about different brands? Anyone remember Shasta? Look at that. What about regular, sweetened soda? Do you get the same experiment? Did I misspoke? What did I do?
Oh, I just don't think she can unmute in webinar mode.
Oh, in the webinar pop. I'm sorry about that. We might sound like peppermint. But yeah, this might be a kind of cool thing, is have different groups do different sodas, and see if you get so. Well, folks, have a good rest of the school year. Melissa's going to be doing Diet Coke versus others. Hey, there you go. What happens when you drop a Mento in there?
Yeah, good luck with that.
Be careful.
Try it first.
Don't get the CO2 sensor wet. That would be bad for it.
Yeah.
The next webinar, Melissa and I are going to work together again, but she's going to take the lead, and it's going to be a spectroscopy related webinar. So keep an eye out for that. That's coming up a couple of weeks, Melissa, 3 weeks.
October 20th. I just looked it up.
Yeah, so that'll be the next one, and we'll do the same thing. There'll be a recording and free files and all kinds of stuff. So, All right. You guys have a good day. We'll see you next time.
Yeah. Bye, everyone.